Hello, so in the last video we talked about if we had n objects and we had r positions to put them in, so in this case we had n objects and we had r positions to put them in, then how many ways are there of arranging those n objects into r positions? Well, we said it was n factorial divided by n minus r factorial. Okay, and we gave this a special name. It was NPR, the P standing for permutation. So the number of ways of putting n objects into R positions, or choosing R objects and putting them in sort of R positions from n objects, if you like. But to me, that just makes more sense to say we've got n objects, we've got R positions to put them in. How many ways are there of doing that? Okay, and it was NPR, or n factorial over n minus r factorial. So in this case, we had 8 objects, so we had 8 factorial ways of arranging them, okay, and we had 3 positions to put them in. We had 3 positions to put them in, so therefore it was 8 minus 3 factorial on the bottom, okay, and this was basically because we just wanted 8 times 7 times 6. We didn't want the rest of the factorial, so it's 5 times 4 times 3 times 2 times 1, or 5 factorial. So if we divided through by 5 factorial, we get a cancellation, and so we just get the 8 times the 7 times the 6, which we were interested in. Okay, now though, suppose that I want to still choose our position. I still want to choose our objects, so I still want to choose 3 objects, but I don't have 3 positions to fill them in. I don't have 3 positions to put them in. I just want to choose 3 objects. Don't want to do anything with them. I just want to choose 3 objects. So let's say, for example, I choose this object. And let's suppose, for example, I choose this object, so this cube. And let's say, for example, I choose, let's choose this cube here. Okay, so I've got my 3 cubes. I'm not interested in arranging them at all. Okay, I'm not interested in arranging them. I just want to hold them there in my hand. Okay, so the arrangements don't matter to me. I just want to hold the cubes in my hand. Yeah? So in other words, I want to work out the number of, how I can choose R objects from 8 objects. So I had 8 objects to start off with, and I just want to choose 3 objects from those 8 objects. So I just want to choose. So I want to choose 3 objects from my 8 objects. Okay, I'm not worried, so I just want to choose. I'm not worried about arranging. So this was all to do with arranging. I'm not worried about arranging anymore. I'm just interested in choosing them. So I'm just going to hold my cubes in my hand. I'm not worried about arranging them. So to me, I'm just going to treat that arrangement there as identical to being this arrangement here. So this arrangement is exactly identical to this arrangement, and this arrangement is exactly identical to this arrangement. So in other words, I want to get rid of all the different ways that I can arrange these objects, because at the moment this formula here includes all the different ways that I can arrange these objects. I'm not interested in arranging objects. I'm just literally want to hold the cubes in my hand. So in other words, I want to treat all the arrangements as identical. So how do I remove the ways of arranging these objects? Well, first of all, how many ways are there of arranging those 3 objects? 3 factorial. That should be engraved in your head by now. So 3 factorial ways of arranging those objects. I'm not interested in all those 3 factorial different ways. Actually, let's just draw them out. So I can have this arrangement here. I can have this arrangement here. Okay, I can have this arrangement here. I can also have this arrangement here. Right? I can also have this arrangement here. Yeah, I can have this arrangement here. What other arrangement can I have? Well, I can have the grey cube first. Sorry, the brown cube first. What other arrangement can I have? Well, the last arrangement that I can have is just having these 2 last cubes swapped. So this arrangement here is just another arrangement that I can have. So these are all the different arrangements that I can have of these cubes. But to me, I'm not worried about arranging them. I just want to hold them in my hand. So to me, all these arrangements are identical. So therefore, I'm going to have to remove them from this formula here, because this formula here took into account all of these arrangements that I can have, but I'm not interested in them. I'm just interested, I think they're just identical. So in other words, in order to remove them, I'm going to have to remove this 3 factorial ways of arranging them. Okay, because this 3 factorial ways of arranging, these are all the 3 factorial ways of arranging these 3 cubes. So therefore, I'm going to have to remove this 3 factorial from this formula here. So I have 8 factorial over 8 minus 3 factorial. Then I want to remove the 3 factorial away. Well, if I want to remove 3 factorial, are you happy I'm just going to have to divide through by 3 factorial? Because all of this formula involves multiplication. Okay, so in order to remove stuff which I'm multiplying, just divide. Okay, just divide. So if I divide 3 by 3 factorial, this is the same as 8 factorial over 8 minus 3 factorial. Well, this is the same as 3 factorial over 1. So if I flip it, it's going to become 1 over 3 factorial. Okay, and then this divide becomes a times. Okay, now I just multiply through. So this becomes 8 factorial times 1, which is just 8 factorial. Then this 8 factorial, 8 minus 3 factorial times the 3 factorial becomes 8 minus 3 factorial times 3 factorial. Okay, so that is my final formula. So remember what I was doing here. So remember what was my n, what was my n and what was my r. So if I color code it, so my n, I had n objects. Yeah, I had n objects. Okay, then I had r. Well, I'm not arranging them anymore. I'm making a selection, but I'm just choosing them. Yeah, I'm just choosing them. I'm not putting them into arrangements. So to me, all of these arrangements here are irrelevant. They're identical as far as I'm concerned. I'm just holding them in my hand. So I'm just choosing them. Okay, and this formula here was just given. This formula here is another name for it, is NCR. NCR. So NCR is equal to n factorial over n minus r factorial, divided through by r factorial. Okay, another way of writing NCR, by the way, shorthand way, is just n r and then just in brackets like that. So, this is really important. So the difference between this formula here, and this formula here, so the NPR formula, which is just n factorial over n minus r factorial, is that this formula deals with arrangements. This formula here deals with arrangements. So I put r objects, I choose from 8 objects and I put them into r positions. Okay, so n objects, r positions with this formula here, the permutation formula. So with this formula here, I have n objects and I put them into r positions. Okay, but with this formula here, I'm just dealing with choosing them. I'm not putting them into an arrangement. I'm not putting them into a line. I haven't got any positions to put them there. I'm just literally holding them in my hand. I'm just literally making the selection. That's all I'm doing. Okay, so I'm choosing. So I've got n objects. And I'm making r choices from those n objects. So r choices from those n objects. This is all this is dealing with. Whereas this is n objects and r positions. Okay, so they're very subtly different, but they're majorly different. The kind of the language is very, very different. I've still got n objects. I'm still making r kind of selections, but what I'm doing with each actually makes the maths very, very different. With this formula here, I'm just choosing them. Whereas with this formula here, I'm actually doing stuff with them. I'm putting them into a line. I'm making an arrangement from them. Whereas this formula here, I'm just choosing them. Make sure that is fully in your head.